Hello. Thank you everybody for coming. I will just start. So this presentation will not be anything fancy. I will just present like some shader basics, mostly focusing on Vertex and Fragment Shader. So it won't be about lighting or like shading or like ray marching or ray casting and these like modern technologies, but it will be more based about that basically the shaders are not so scary, that they are like really easy to program, and that they are actually also a lot of fun, and that you can do a lot of like cool effects. And can we get lights? Can we turn down lights? And for all the non-technical people, there will be a lot of like GIFs for artists. So yeah. And first I'll just start with the basics. This on the left is basically like a basic graphics pipeline, really like not too much details, and all of the yellow stages are the ones that we can program, and I will focus only on Vertex Shader and Fragment Shader. I will leave out the tessellation and geometry, I guess, for next time, because this is like whole new topic for this. And this is basically this how like your GPU transforms all the data from your models and meshes and textures. It basically takes in vertex buffer, which is basically just like floats and just like numbers, and it packs them into this, let's say, into packages, and then it gets assembled, and then in Vertex Shader we can manipulate them. And you can imagine like this as in Blender, when you can grab some vertices and just move it around. So this is basically Vertex Shader. Here you can, let's say, manipulate the data, and you basically do operations on vertices. And here, this is like a lot faster than doing stuff in Pixel Shader, because let's say we have like I don't know, 10,000 or like 100,000 of vertices. It's really small compared to like each pixel that is like rendered on in Fragment Shader, because there we have, let's say, like we have like 1080p. So this means that we have like 1,920 pixels times 1,080, which comes easily around a million like operations in just in Fragment Shader. And in Fragment Shader, you can imagine this as just coloring the pixels, right? So you will basically select color for each pixel on the screen, and here we basically get data from, let's say, from your Vertex Shader, and you basically input it and do some manipulations over it, and yeah. And I'll just talk quickly about UVs and textures, just to get the, yeah? Yes. Okay, so basically UV coordinate system is just like unified system which goes from 0 to 1, and this is because we have like different like texture sizes. Like you can have like 1K texture or texture which is like 150 times, I don't know, 60, and this is just like unified system. For all of the textures, and here like you can see like this would be like one like kind of like pipeline for, let's say, textures. First you have like model, then you have like, let's say, albedo or like your color texture, then you have like normal, and then you have metallic over there, and roughness, and then at the end you get like this fine model, and this is usually called like PBR material, like physical base rendering. This is basically like your standard shader in Unity. And before we go on, just one like quick disclaimer. I basically learned everything by myself. I watch a lot of like Reddit posts, Twitter posts, and tutorials online, and they are like not super optimized shaders, not, I guess, for any like mobile stuff or anything like that. And if anybody has like other suggestions or how to improve it, I'm open. And here I have like just some materials that I used while I was learning. Like really cool is like the book of shaders. cat-like coding, render hell, and so on. And yeah, and this is basically my average day at outfit. Basically, the most that two at the bottom, like I just type with my headphones on, and usually like I just push computer out when I have enough. So yeah. And okay, so the first one, it's really basic one you see in every like YouTube video, like online, like you probably seen it like a million times. It's a dissolve shader. So you basically, what you take noise, and you say, okay, where you see like these white spots, I will basically render the white spots, and I will the black ones I won't render it. And how you do this is basically by clipping the pixels. And yeah, this is just doing by like this really like simple operation. Let's just see. Select. I'll just quickly like show how it's done. Okay. Okay. This one. Okay, okay. So here you can see. So basically, what you do, I mean, this is not like super like optimized. I could also like just take, I guess, just alpha. But what I did here is I just said, okay, I use this clip function, and I took my alpha from noise, and I said, okay, I will take like just the sign time, and if this value like which is here is lower than 0, then the pixel will get discarded. But if not, it will get rendered. So we can just see this here. Just do this. Here now we can just see like that it's rendering just the pixels that are like not discarded, where this noise texture is less. I mean, it's more than this factor. And we can also like control this by using this dissolve factor. And here you can see, then here I can like adjust, let's say, how much of the dissolving I want. So basically, if this here is 0, then discard. If not, it's more than this. And what's really cool is that I can, what I can do here is then, so the next step, what do I do? Like I want like this really cool like outline, so that it will kind of like show. It will kind of like show that it's like slowly like fading out. It's more like that's kind of like burning out. So how do you do this? Is just we offset our noise here in this function, and then we are just basically here lerping from the original color to that color of the edge. So if I can just show it here on the, basically, if you lerp it to the, let's say, to the opaque color, I mean to the transparent color, it will look something like this. You can just see here that it will just go, just this pattern that will go up and down. And then at the end, you just combine these two together. And that's basically that. Then you get like this really simple dissolve effect. And the next one is also one of the really most popular ones, is holograms. So how we do this one is, so basically we take in our world coordinates of the model. So this is why we see here that there are like red and blue and green, because the x coordinate is x, I mean is r, is red color, y is green, and blue is z. So we first take in the world coordinates, and then the main effect is that we apply sinus function over it. So if you imagine like sinus function is like, it goes like from 1 and then goes to down below the 0. So where it's like more than 0 it's white, and where is less than 0 is black. And this is again really simple. Let's see, it is hologram. So basically, we take here like word position, and we offset it so that we have like this kind of like scrolling effect. This is like common trick that we use, just time that passed, and that we can get like this like down scrolling effect. And then just say, okay, I will take sinus of this, and this actually function just does that. It's clamp it from 0 to 1. And this, if we just output this out, it will return. It will return just this kind of like scrolling effect. Up. It will go up and down. So yeah, and now to make this like, I mean, this is now like the base of the effect. So now to make it like more like prettier and poppier, we will use, here you can see this the third one is the scan line. And here the trick is that we just use a frac function, which is basically, it returns, if you have like some decimal number, it returns like what's the remainder. Like if you say we have like 1.5, it returns 0.5. So this, what we'll do, it will create like this really cool gradient effect. And then we can combine this gradient effect with our like these hologramic lines. And this is, we do it like here with this distorted line. We just use again our offset, and when they multiply with the distort speed, and just say, okay, I will take frac out of this. And then this power here is just to like that you can like control how much we want like this distortion, and this basically looks like this, like just goes down and up. So yeah, and now we can together combine these two, so that we get this kind of like more like jagged. It's not like all the same, but it's like more like kind of like this jagged line. And then what we can also like, this is also again like some of like kind of like how to like make it like more beautiful. Here we will add like the Fresnel effect, which is basically it's basically like the rim color of some model. You can see here on the sides there are like these really like kind of like beautiful outlines, and also on this bunny. And what we'll do again is we will add this Fresnel effect to what we already have, and this is a little bit like it's a little bit like of this function. I just took it from the Unity node-based shader, which they have like online. They have like this. You can convert your like nodes to the code. So I took this function and I just copied it here. So basically what it does, it calculates the dot product between your VO direction and normal of the object. So the normal is like 0 if they're like perpendicular one to each other. So on the edges it will be 0, but then we like turn it and we say like, okay, 1 minus this, and so that's why we get on the outsides we get like more like this beautiful rim. And yeah, and these Fresnel effects look like something like this. And then we can also like control it here with like how much power do we want to it, and how much do we want to have like this blue outline, I mean the white outline. And at the end we just are adding just the final color, and we just multiply this Fresnel effect with our color, and we will get like the final result, which is like this blue. Oh. Thank you. Here, and then we'll get like this blue kind of like outline. Blue kind is like blue model. Yes, and this is it for this one. And the next one, which is also like really like simple and really like cool effects, are like caustics. So what I did here was, I found some caustic texture online, which looks like something like this. I took it online. This is basically my texture, and I'm just like moving the UVs in one direction. And for the second step, what I did is I took another texture and I overlaid over the top, and then like move it into the other direction and take minimum of these two textures. So how this looks in code, so yeah, here I sampled like two caustic textures, and I'll just do this, and each of them has like their own like speed and offset. So this will look something like this. Oh, okay. And what is really cool about this, because I'm taking like the minimum of these two, right? It looks a little bit like more darker, because like the lower values are darker, higher values are more like bright. But like you get like this really cool kind of like moving and kind of like forming effect. And if I here do like maybe like minus it will go really in the other direction. It will have like even more like kind of like this slow and like so kind of like forming effect. And at the end, what I did just to have it like a little bit more like beautiful, I added the color split, which is not, I mean, what I did is like I sampled the texture 3 times and just offset it by a little bit. Like I offset like R, G, and B for a little bit. So on these white spots that you see on the second one, I took, so I said, okay, I will offset like red color for a little bit, green color for a little bit, and blue color for a little bit. And this looks like this. Basically, I did this. I said, okay, I will take my UV and offset it for something small. And I will take like green UV and offset it for something small, and again for the blue one. And like chromatic operation. Yeah, basically. And yeah, and this is how it looks. Oh wait, no, this is with the texture. But if you just do the caustics, right? This is basically how it looks. Here that we have like before like these white spots, right? Here now we have like this like kind of like, you can see like green and red like colors more like, and also blue. And at the end, I just added like the color from my texture, and it gets like this really like cool like shiny effect. Yeah. And this one, yeah, it's one of my favorite ones, like the fire. It's again using the noise, which is basically like kind of like a bread and butter of all of these like tricks, because it adds like something like organic randomness to the texture, to the effect. So first, what I did is I just used noise and color, and again I clipped the pixels out, and then I did not that like optimized stuff. I actually I generate the noise texture like each frame and move it up, so that I get always like this random effect. I tried with just moving the UVs up, but it wrapped and it didn't look like that cool. Yeah, too repetitive. It was like I was getting all the same, I was getting like the same pattern all over again. Like it didn't look like so okay. what I did, I wrote like small script for this to create this noise texture. Let me check. Scenes file. So here I created like this noise moving, which is basically what it does. I'm just like moving it up, and here I'm just like creating like Unity has like this really cool function Perlin noise, and I'm just creating this Perlin noise out of it and setting the pixel in that texture. And the fire shader looks like this. Yeah. So here first, if I just clip it with like this. First, this is just like the normal fire, and it just go up. And this, yeah, you can see that here, like it's not that it's like something, and this is why I used here like the gradient, so that I have like a solid base, and then more that I go up, more it's like more like kind of like this bubble, and more like this noise takes over, right? So at the beginning the gradient gradient has like this like really like solid color, and then more that I go up, or like less and less like the gradient like affects the effect, and more like noise comes over. So what I did here is I use here like I sample the gradient, and then I just said, okay, I will multiply noise effect with gradient, so the gradient will tell me how much noise is actually in my fire. So this will look like something like this. Like this, and the gradient texture is basically this, like this, just this kind of texture. So yeah, here you can see like that the base is really strong, and the upper one is like have like this a little bit more. And then what I did at the end is I just enhanced the green channel to get like this really cool like to get like this kind of like more like yellowish fiery look. And here again I used just noise and gradient, so that more that I go to the top, more like yellow it will be. So like something like this. And this is basically, so these first top steps are basically how I get like color of my fire, and then here the bottom ones, how I will get the, let's say, the shape of it. So I started like with bottom. I want like have like this like kind of like circular shape. So start with like simple radius, and the pixels that are in the middle will be like displayed. I mean, like we'll have like this stronger alpha, and the pixels more to the side will have like less alpha. And then I moved it to the side left to right, so that I was trying to achieve like this kind of like moving like left to right effect. And then the trick here was also that I applied the gradient, so that more that you go to the top, like more of this kind of like left to right effect it had. And then at the end, I just combined everything that I had here just into this like spherical mask. And here you can see that it's like offsetting left to right, and I also can control like how hard it is on the edges. So this is here, right? So here I'm just like using the center, I'm using the gradient, and then using the sinus function to go from left to right, and using the noise and wobbly scale, and I'm plugging this value into this fire center, and then to this like to this spherical mask. And if you can just check how this mask looks like something like this. Looks like something like this. And wait, I'll just not clip it. And then here I can also like control how wobbly it is. Like we can like make it like more wobbly, and how hard it is. Like this hardness, like it just how much like the blur is on the edges. So I can have like something like this. And then at the end, I just say, okay, this mask will serve me as my alpha, and then just the pixels that are like this, that in the mask will be displayed, and here I can get like this really like kind of like this wobbly flame, like that could go on the candlestick or something like that. And yeah, and there like then what's really cool, like I want to create like also like the heat distortion like effect, and this goes this goes really well with the fire. So first step was that that my plane was always like facing towards the camera, so that I would, no matter what, from which direction I would look, it would always look towards the camera. And then what I did is I used GrabPass. So basically, what GrabPass does is that it takes what was already rendered behind and stores it into one like texture, which you can then later display.
How much is that expensive performance?
Yeah, I mean, yeah, it depends on the area and how much. Like, basically, it's like, imagine that you can have like, it's like basically one render pass more, right? So it's like, first you need to like grab what's behind you, and then, so you need to like display once and then sort it into texture and then use it, right? It's same like as you would like render to one texture, right? If you have like the minimap, right, somewhere like, it's same like grabbing and then just storing there. So it's one shader pass, so yeah.
So just from the start you render into texture everything.
Yeah.
And at the end, use it when you need it. At the end, just
split it to the camera. Yeah, yeah. I said like thanks you for this comment. I mean, I used what was like the first, and then like think about the optimizations and how would work this on mobile or whatever. But yeah, thanks. So here is the plane, and I'll just quickly show how we can do the how we can do this, like always like always face to the camera. Heat distortion. So here in the Vertex Shader, what we'll do is we will first take, we won't take, like usually we will take like, here we will say like, okay, you need the object to clip position. Clip position is basically the camera position, right? But here we'll take object to view position, basically to the viewport, and this we'll take as our origin. And then what we will say, okay, we'll add this origin to our vertex, and we'll project this with the with the projection matrix. And this is how you'll get like where is our like position turn. So yeah, and if you can see, like I can just do a quick demonstration. If I just like do some random color, yeah, this is how it will look. It will always rotate towards you, right? So it will always be like towards the camera. Yeah, and so and then how you do like the grab pass is here you can say, okay, I will say, okay, I'll do like one grab pass in the background texture, and here you just need to like compute your position, because later you will use it as when you will like map the UV vertices, and that's basically it for the grabbing. And then we will now offset the UVs of this texture. So first, if you just offset it for the mask, it will look something like this. So it will have like this like circular motion that you can see here, and it doesn't look like quite like normal. I mean, like it looks like that it's like just circling. So what we'll do is we'll just add some noise to it, and this will make it a little bit like more normal. So here you can see like this now like creates like a little bit like better like kind of looking effect, like it's all like kind of like random. It looks like when you're like maybe in like a desert or like on like at the fireplace, like it's like this kind of like distorts the area. And here you can also control how much and what's the speed of it, and how like strong. You can also do something like this, which will like destroy like completely like it will be like completely like the noise will take over and it will be like totally like messy. So yeah, and then you can basically combine it with the fire together. And now just the last effect is like really like dev-wise is like really simple. So it's like basically you see a lot of games like when you go behind some cover or when you go like you have like this maybe like detection like or some radar that they have like this kind of like silhouette around some objects, and how we do this is basically we say okay, we will use like stencil buffer. This is like special buffer when you can like do whatever you want. I mean, you can put whatever values in it. We also have like other buffers like Z buffer and A buffer and some others. And here what you can do is like the car will write to this stencil buffer. It will write some value in, and then this building here will read this buffer and will check okay if this value is the same as the car's value, then just write like red color or like blend it together. So this is again not that hard. Like here you can just like you write some value to it, like, and you say like that you can like always like replace it. And then in silhouette you just say okay, if this is equal to some value and compare it if it's equal, then write here some color. And yeah, and that's it. And basically, it will always like do that. And basically, this is what it is. It's like it's just one more pass in shader for this building. So yeah, and this is it. And everything will be online. I will also post this presentation. And the code is also online. So thanks for your attention. And any questions? Yes.
I would just like to add something. The reflection shader that you showed for the fire.
Oh yeah?
There is one performance. Yeah. There's like one performance issue with it, and this is because you are sampling the texture. Okay. Depending on the noise value. Mm-hmm. This actually destroys all the caching on the GPU. So this why it gets quite a bit slower on devices. Mm-hmm. So you have to watch out.
Okay. But what would you do? Like what would you change? I mean, how?
You can change it. It's not solvable.
Okay.
So usually when you sample texture, you sample all the neighbors, but now you can't actually do the prefetching. I mean, the GPU does the prefetching, but it always misses because you're sampling something else on random position, pretty much.
Mm-hmm. So maybe it would like solve it if I would have like one, like let's say like big texture and just maybe like sample it. Like,
you can solve it by mostly by just keeping the area really small.
Yeah.
Yeah.
Okay. Cool. That's it? Okay. Cool. And yeah, this is the end of the official part, and now we can go to grab some beers.